All right. Do we remember the equation for the circle?
Um, for a circle?
Yes.
In parentheses, x minus h parentheses squared plus parentheses y minus k parentheses squared equals r squared.
Correct. Very good. So pretty straightforward idea there on the equation of a circle. How do we get the x minus h squared and the y minus k squared? Somebody besides Abby.
H and K are the center.
Okay, so if we are given the circle, h and k are the center, very good. What happens if I'm given an equation? What do I have to do?
You have to complete the square.
Very good. So we cannot forget completing the square. We'll go over that plenty today from different problems. So we're not going to do that just yet. We'll look at just kind of doing some problems here in a second. And obviously r is the radius, no big deal. So that one's pretty easy.
Are
The
you
harder
live right now?
it should be.
Oh, okay.
You may have to refresh because it was down. If you just were on the page, it won't automatically update. All right. So for an ellipse, that one being a little bit more difficult, but it's very similar.
Isn't it basically the same thing, but with divided by a squared and divided by b squared?
Yes. There's one other major difference. Anybody know what that?
Isn't it minus?
No. That's the hyperbola. Gotta be careful.
Oh, okay,
It's
never mind.
equal to
Is
1.
it equal to 1?
Oh, yeah.
Correct. So the other major difference is that equal to 1. The a and b values are actually going to come from dividing by the r value that would have been there on a circle. So when we divide by that, that creates those a and b values. That's why we have to have it equal to 1, so we know what the a and b are. Do we know what a and b represent?
Yes. A is the length, wow, from the center, there's no center, hold on. From the middle to the focus?
No, not focus. Close.
The vertex?
Well, we got to be careful. It's not always to the vertex. So remember, how do we determine a vertex for an ellipse?
I don't remember.
Okay, so
Someone else say something.
you're fine. Your vertex is determined by your major axis, which is your longer part of the ellipse. So in other words, if it's squished and it's a horizontal ellipse, then it'll be longer left to right. In your vertex is the point that's on those. What most people refer to them as, you have your vertices like that, and then you have your minor vertices. Your minor vertices would be your shorter ones. So it depends
I have
on
the picture in my head. I just don't know how to say it.
So your a value, regardless if it's a horizontal or a vertical ellipse, your a value is the value from the center, and then either you go left or right, doesn't matter which way, to get to the end of your ellipse. And then your b value will be the same thing, but since it's with y, it's your vertical value.
Okay.
Now, one that is how do you tell which one is your major axis based on the equation?
If it's the y parentheses first.
No, that's careful. That's hyperbola. That's honestly where the biggest problem is going to come from in this chapter, is remembering which one is which and which one goes where, especially with the ellipse and the hyperbola, because they are very similar.
Is it like which value is larger, or A or B?
That is correct. Good job, Mr. Colvin. So whichever one is larger is your major axis. So for instance, if A is bigger, that means it's a horizontal ellipse. If B is bigger, that means it's a vertical ellipse. In other words, it's squished vertically. So it's going to be taller than it is wide, or wider than it is tall, depending on which kind you have. So that's how we get those two values. Now, along with our ellipse, we do have one other value. So we have A, B, and then obviously C. Does anybody remember how to find C?
Square plus C
Pythagorean
squared.
theorem, but minus.
Pythagorean theorem, but minus. I guess that's not wrong. So for that, our value is c squared is equal to a squared minus b squared, or squared, b squared minus a squared. So remember, it doesn't really matter which one, you don't have to like memorize which one goes first, just whichever one is bigger will give you that correct value. So that's why you have to have both of those equations. So if a is bigger, a goes first. If b is bigger, b goes first. So it's pretty straightforward. Just always do subtraction.
Can't you also do absolute value for just like?
That is perfectly fine to do, yes.
Okay.
Okay, and what is the C value?
Doesn't it help with eccentricity thing?
You use it to calculate eccentricity, yes, but what is that's not what it that's not where the value comes from. So your C value, as a reminder, is your focal distance. So it's the distance from the center to your focus.
Oh.
Okay, so to kind of put it in perspective for everything, so I'll kind of do my best to draw these and put the values on them for you. Okay, and then we'll do.
So when you do get C, you just like count out the units,
Correct.
and then that would be where your foci are.
That is correct, yes. Good use of the plural word foci. Okay, so as the picture gets up in a second.
Do you only have foci on the major axis?
Yes, ma'am.
Okay.
So this is B. And these pictures are in your book as well. So I know I don't do them best. That's C. And that is A. So the one on the left should be popping up in a second while I'm doing the one on the right. So your C value will be from the center to your focus. Your B value will be from the center up to the top. And then your A value will be left and right. Let's see. That's a terrible B. I'll do it that way. Let's see, I got blue. Let's see.
Charlotte, go away.
And then yes, Charlotte.
Charlotte, go away.
I guess I can do that. So there's your A, B, and C values as far as on the diagram for the ellipse. Okay. Do you have any questions about how any of those values connect to the actual ellipse itself?
So there's minor vertices too?
We don't really label them as minor vertices in this and on ellipses, but that's what a lot of people would refer to them as because they are the vertex that's on the minor axis.
Yeah, because well, on the right one, it's the distance of A is.
Correct. So that would be the distance
Okay.
from the center to what most people would refer to as the minor uh, vertex. However, the book does not call it that, so she probably won't ask questions or even refer to it as that. I would refer to it as that just as a point to make like, hey, that's what this is. Because other functions that are in the conic section do use minor and major vertices and things like that. So I would call that a minor vertex.
Okay.
Any other questions about how those values relate or how we find them before I start working any problems?
Did you misspell ellipse?
Yes.
Ellipse.
No, it's Ellipse. Thank you for catching that about 10 minutes in.
I'm half asleep, okay?
You're good. That's really funny. Um, is there any specific questions from the homework that somebody has already worked that they need help with?
Would you, by any chance, have the quizzes on you?
No. Everything's at school. Are you talking about the truck problem going through the bridge?
No, I got that. I just didn't get the first problem on the back side of the quiz.
Do you know what it was referring to? Because I don't remember off the top. Actually, hold on. I think I have them in my email. I can look at them if you give me half a second. I forgot about that.
So you're not going to be able to grade them until we go back to school.
Oh, no, I can go back to school.
Oh,
Oh, I lied. I can't get to the quiz. Apparently, Gmail and Google are having severe issues at the moment. That's why I couldn't do what I wanted to earlier. Let me try refreshing. Yeah, they're having issues with Google, so I can't get to the quiz. I'm sorry. Do you know what the problem was approximately referring to?
It would, I think it gave the foci and the major axis length.
Okay, I can do one like that. Yeah, not a problem. Oh, there we go. Just came back. I'll actually work that problem for you. I don't care. I think everybody's taking the quiz. I guess it would help if I was in the right email. Okay. I don't know. That's weird. There we go. That worked.
Hey O'Donnell,
Yes.
I've not taken lesson 16 quiz.
Oh, sucks for you. Uh, yeah, I gave you the length and the foci. That's easy. Yeah, there's problems like that we can do. And thank you for being honest, Gretel. You're still going to fail. All right. So we'll just start out working a couple problems. So if you're following along in the book, I'm not going to do numbers 1 through 6. Those I think are relatively easy. Just as a point to make sure, if I give you the foci, how do you find the center of an ellipse?
isn't it h plus or minus c for the x value and then k?
There's a much easier way.
Oh,
What do you know about the center in relationship to the foci?
It's in the middle.
Yeah, it's directly in the middle.
Angle the 2 points.
Yeah. So you're,
Can't you find the midpoint?
yes.
so
I mean, you
the
don't really have to
center to
find
the
the midpoint.
foci is the same as the foci to the major axis.
hmm
Vertex.
So the foci are the middle of the foci is the center because both of them are out a distance of c. Same thing with the vertices. The vertices are direct opposite sides of the center, so right in the middle of both the foci and the vertices is going to be your center. We can do that, not a big deal. Okay. No. All right, so we'll start with like number 11 if you're following along in the book. So if you want to write this down also as part of your homework, it's number 11. So make sure. So it tells us the foci are at 0, minor is length 4. Alright, so the problem tells us that it has foci at 0 plus or minus 4, and the minor axis length is 4. So
Are you
what?
doing number 11 in the book?
Yes, ma'am.
The practice
Oh,
exercise?
I looked at the wrong thing. It's 6, not 4. Which is, I'm assuming, what you're referring to. Thank you. So the foci are at 0 plus or minus 6, and the major axis is length 4. Okay, so what does that help us find out?
You have a vertical major axis
Why do I have a vertical major axis, Kelvin?
because the foci is plus or minus 6 in the y value.
So very good. So that means the foci are vertical above and below each other, which means that my major axis goes along that way as well, so it is a vertical axis. Now, as a suggestion, as you're doing these problems, because they want us to write the equation, the very last thing I need is going to be this right here. So I'm going to
The
go ahead and
center
start
is
writing my equation, and then fill in pieces I know. So go ahead, Abby, what were you about to say?
at 0, 0.
Somebody else, how does she know the center is at 0, 0?
Because the foci are plus or minus 6, so if you add 6 to.
It'll be
Is
0.
that right?
Yes,
Yeah.
you're 100% right, Madeline.
I just
So
don't know how to say it.
you're okay. So the
Wait.
midpoint of 0, 6 and 0, negative 6 is 0, 0. And somebody said, wait, what am I waiting for?
Wait. How do you know if it's like if it's a vertical
Because
or if it's horizontal?
if you were to graph your foci, would those foci be vertical or would they be horizontal?
I don't know.
You don't know where 0, 6 and 0, negative 6 are, Brisa?
Oh, I retarded.
We already knew that. It's okay. Remember, this is on stream, so people can hear you and, you know.
Okay. Yeah.
So our center, based on the fact that our foci is there, we can get our center being 0, 0. So I can go ahead and plug those values into my equation that I'm going to be writing. So my h and k values are both 0. Okay, so now what else do I need to find?
A and B.
Okay, how do I find a and b?
You have to graph it, basically.
No, you can if it helps you. That's not a problem, but you don't have to graph it. And I'm not going to go through the process of graphing it.
Well,
Now,
it says minor length equals 4, and the minor is the horizontal axis, right?
correct. So this tells us
So
that, not b.
would A be 2 because it's 4
So
equals
very
4?
good. So a is equal to 2. Because remember, the length of the axis is equal to 2a. In this case, our minor is a, so 2a equals 4, which gets us to a being 2. So don't forget to cut that value in half if they give you the lengths, because the a value only goes one way, not the entire length. So I can go ahead and plug that in down here. So I'm going to write 2 squared. Now how do I find b?
The a squared minus b squared.
Okay, but how do I get c then?
You have the foci in the center,
So
so it's 6.
So c in this case, very easily, very good, Madeline, is 6. So from 0, 0 to 0, 6, or 0, negative 6 is a value of 6. And then at that point, we use that c squared in our case will be equal to b squared minus a squared, because b is our major axis. It's going to be our bigger number. And then just plug in your values. So you get 36 is equal to b squared minus, I'll just put a 4 there, 4. So b squared is equal to 40. Don't make the mistake that I see a lot of people make. I don't need to find the value for b. I just need b squared. So this will just be a value of 40. You can solve for b if you want to and simplify it and do all that and take the square root if they ask for it. This problem just wants the equation, which we have now written. You can obviously change it and make it a little prettier if you wanted to, so it would just be x squared over 4 plus y squared over 40 equals 1. And that's the answer you would see in the book. So they're not going to write x minus 0 or y minus 0. That's redundant.
How did you get 6?
The distance from the center to the foci is your c value. Center's
Oh,
at 0,
here.
0, foci's at 0, 6.
Oh, yeah. Okay.
Okay, any other questions on that one? Okay, so I will leave the rest of that type of section to you. Just remember like I said, the important facts there are that the center is directly in the middle of your foci, also your vertices, and don't forget to cut your minor or major axis lengths in 2. Okay, so let's see, we'll do one where we have to do a little bit of factoring. So I will do number 19. Do you have the book open, anybody? Looking at the problems. Nobody? Okay. X squared plus 4y squared. 150, 16. And then plus 141. Okay. Alright, so if we start off with that as an equation, and they want us to write the equation of the ellipse in standard form and then find all the stuff. Okay, so what's my first step going to be? Does anybody remember?
Rearrange or move your C value. Or is that the C? I don't know.
That would not be the C value, but I'm assuming you mean the 141.
Yeah, the 141.
Okay, so yes, very good. So rearrange everything and move the 141 over at the same time is what I would do. So get all the x's together, all the y's together, and then that. So we get 25 x squared, 150x plus 4y squared equals negative 141. So that is correct. Okay, now somebody different that hasn't been speaking today. What do I do next?
Complete the square.
I said somebody that hasn't been speaking.
Oh yeah, you complete.
Complete the square.
Oh my god, you guys are geniuses. I wonder where he got that from. Okay, however, I have to do something before I can complete the square. Now let's see who knows that.
Factor.
Factor of the GSF.
Yeah.
Got to be careful, but yes. So blanket statement, we're factoring out not necessarily the GSF, but always whatever's in front of the x. Now, in your cases, yes, they're going to be common. It's not going to be that hard. But these numbers don't have to necessarily match up and have something in common. Now, our problems, for our sake, are almost always going to have that happen, but they don't. You have to factor out the 25 because in order to complete the square, the x squared term has to be a 1 in front of it. So 25 out of the x's and 4 out of the y's. 6. And now is when I'll put my blanks in. So y squared minus 4y plus blank equals negative 141 plus blank plus blank. What is going to go in my first blank?
9.
How do we get 9?
You do 6 divided by 2, and then you square that.
Very good. What about the second blank?
4.
Okay, what about this third blank over here on the right-hand side?
You add those same values.
So 9.
200. No.
Mhm.
9 times 25.
Have to be
And 4
careful.
times 4.
Very good, Miss Madeline. You did not just
Oh,
add
yeah.
9 here, you added 25 times 9. So that'll be 225, and then 4 times 4, which is 16. Alright, so I don't feel like doing this in my head. 225 plus 16 minus
It's 100.
100. Thank you. And I'm also going to go ahead and factor. Remember, why did we make these two sets of parentheses look like that? What's the whole idea of doing that?
To get like x minus h squared and y minus k squared.
Right, so they will be perfect squares. So when you go to factor them, it should not be a difficult process of factoring because it's going to work the same way every single time. So remember, in order to factor them, it'll always work out to where this variable is going to go first. The number you use to get the 9 in the first case will be the number you said would be plus 3. And same thing on the second one. So I used a negative 2 to get that 4, so it'll be y minus 2. And what's my last step now?
So we have to divide by 100.
Okay, so we can't forget that this over here has to be a 1. So divide everything by 100. And then simplify your fractions. Plus minus 2.
What would happen if when you like if your 100 was a 1 already?
You would just leave it.
Is that possible?
Um,
Because then you wouldn't divide by anything, so would A just be 1 and B would be 1?
if that was already equal to 1, then yeah, you would have them both being equal to 1, but that would create a circle.
Oh.
Because then your major and minor axis would have to be the same for the most part.
Oh, yeah.
So that would just be a circle.
Okay.
But yes, that can happen. Okay. So now at this point, we need to discern a bunch of information. Okay, so what is the center? Do the easy parts first.
Negative 13.
Okay. Let's see. So we need center. Let's see what vertices. So JDev, what are the vertices? Okay, you can type out what the vertices are. It's okay. Let's see. While he's doing that, Brandon, what is the length of the major axis? Brandon.
Brandon, you have yourself on mute.
I think he knows that because he's playing League of Legends right now. So is JDev. That's why I'm calling them both out.
Why does the live have like 300 views?
That's the total number of views I've had, so every time you view it, it adds to it.
Can I answer then?
Yes, go ahead, Harrison. I was getting ready to call on somebody else since you offered so nicely.
So isn't the major axis, half of the major axis would be B for this, so it would be 10 in total?
Correct.
Am I
Very
just
good.
being-
No, you're good. So
Yeah.
B value would be 5, so double that, you get 10. So perfect. Length of the major axis is 5.
10.
That's what I said, isn't it?
You said 5.
Oh, my bad. I'm brain farting. So yes, double
Is
5
it-
would be 10.
Is it going to be vertical?
Yes, it will be vertical. Why is it vertical?
Because B is larger.
Yeah.
Yep. Let's see.
Where did we get 10 from? I'm confused.
See the value under y minus 2?
Yes.
So that's b squared. So b squared is equal to 25.
So wouldn't it be 5?
Right, so b is 5, but that's only half of the ellipse distance. Remember, b only goes one way, so you have to double it to get that. Okay. So then, Brandon, what's the minor axis then?
I just got back. I don't know what's going on.
What was the question? I think I got
Oh, Jadev's mic magically works now. Look at that!
Wait, what was the question? I think I got it.
What's the length of the minor axis, Jadev?
No, that wasn't the question.
Yes, it was.
That was the vertice one. And it would be... I don't know.
Somebody want to help Jadev out there?
4.
So
What's
explain
4?
explain how you got 4, please, Maddie.
Because A is from the center to the... Well, A is half of the minor axis. And since A is 2, you multiply it times 2.
Very good. So remember, take the square root of the 4 underneath the x plus 3. So square root of 4 is 2. That's half of that minor axis. So then you do that times 2. So 2 times 2 is 4. And also, good job, Kason. So now in order to get the foci or the eccentricity, we need our C value. So how do we get our C value?
You need your major vertices.
No, not for C.
C squared equals B squared minus A squared.
Yeah, C is the square root of 21, I think.
That would be correct, yes. So take your b squared, in this case, since b is bigger, b squared, which is 25, minus a squared 4, and then take the square root of that, so 25 minus 4 is 21, square root 21. Okay. So how do we, the foci in this case are very ugly. So remember, to get your foci, you go along your major axis, so that'll be the y value. So in this case, what you have to do is take the 2 value from your y and go up and down that square root of 21. So you'll have 2 plus the square root of 21, and then 2 minus the square root of 21. And you would leave it just like that. Do not mess with it unless they ask for a decimal approximation. You'll leave it just as 2 plus and then 2 minus. And the x value will stay the same, that negative 3. So remember, on your moving up and down, the x value does not change, only the y value does. Okay. And then eccentricity, do we remember the formula for that, since I think I left that out on accident earlier?
C over A or C over B?
Correct, so it's either C over A or C over B, and you always use the bigger one. So use whichever one's your major axis. So in this case, it'll be C over 5. So square root of 25, 21 over 5.
Question, what was the foci again? I missed that.
The foci will be, the actual exact coordinates will be -3, comma 2 plus square root of 21, and then -3, comma 2 minus the square root of 21.
So are the vertices -3, 7, and -3, -4? Because you go up
-3,
B and down
-3.
B. -3, -3.
Mhm.
Oh yeah.
2 minus 5 and -3. Yes,
So
that is
those
correct.
are the vertices.
Mm-hmm.
Okay.
Okay. I think that was everything we needed to find.
Wait, what are the vertices? How did you get that again?
Remember your vertices. In this case, it's a vertical ellipse. So you're going to start at your center, which is the -3, 2, and then go up and down. In this case, your B value, because it is a vertical ellipse. So -3, 2 being the center, I go up 5 and down 5 for that B value. So it'd be -3, comma 7, because I add 5 to the 2. And then -3, comma -3, because I do 2 minus 5.
All right, thanks.
Mm-hmm. Any other questions on that?
If we were to graph this, is there a way to double check the graph?
Not an easy one.
So basically, no.
No. I mean, you could put the equations into your calculator, but it's going to take a lot of work, and I don't know if it'd be really worth it.
Cool.
Yeah, pretty much a couple areas that you'll notice you'll be making mistakes. Usually we try to keep them to be relatively nice numbers for A and B. C doesn't necessarily always end up being a nice number, but we try to keep the values for A and B nice most of the time, especially on the tests. I don't think she would choose really ugly values for A and B because that just makes everything a lot harder for no reason. And then looking at everything in the book, yeah, every single problem in the book has really easy A and B values. For the most part. Oh, no, 23 doesn't. I lied. But we try to keep them relatively nice. So if you start realizing you get some things that are off, that's usually when you can tell. Not always, but there are some online graphing utilities that can graph them, but not to put it in your graphing calculator would be kind of difficult, to be honest.
Okay.
And for the most part, that's all the rest of the types of problems is doing that. And then the applications of those, like the truck problem that you saw. Any questions on what I did or what we went over today?
No.
All right.